Assalamualaikum, my name is Shahzeb Hassan and my registration number is 21T67. This is my lab report 2 of digital signal processing being submitted to Sir Jameel. I have performed all my tasks on the MATLAB online trial and then pasted the screenshots on my Word document so I can create a lab report. Now starting with the task 1. In task 1, N0 is representing the value of the axis, N1 and N2 are showing the value of the limits. Then I have defined the index value, then I used a step signal and then used a stem command to plot the following signal. The output is being shown in the following figure. Through this figure you can clearly see that the limits are from -3 to 3. Now moving on to the task 2. Task 2 is as same as of task 1. In this just the values are being changed. At N0 we had defined the values of the index. At N0 we had defined the value of the axis, which is 1. N1 and N2 are the limits. Then again we have defined the value of the index and then use the stem command to plot the following signal. In output you can clearly see that the limits are from -5 to 5. Moving on to a task 3. The task 3 is also the same as of previous ones. N1 and N2 are the value of the limits. Then I defined the values of the index, then use a stem command, and in this the x function, which is 3 multiplied by cos 3 pi sine n5, is being used and the output is being shown in the figure. And again the values of the limits are from -3 to 3 as I had defined in the code. Moving on to the task 4. In task 4 we have to plot the unit impulse function. First we have to define our function, which is our function. Function is equal to function x equal to unit impulse n0, n1 and n2. And then we have defined the index values, ended our function, then we called our function and used the stem command to plot our function. This is the following output. Moving on to task 5. In task 5 we have to plot unit step function. Again we defined our function as function x is equal to unit step n0. Then I used if loop if margin is less than 2 and is equal to 0 and last I called my function and use a stem function to plot our following signal. In task 6 we have combined both these functions as unit step and unit impulse. N is equal to -3 to 3. The limits have been cleared and I used a display command to plot the following signal and the output is shown in figure. In task 7 we have to flip our signals, mean to say that the negative side values will be flipped to the positive side and the positive side values will be flipped to the negative side. In this I have n is equal to -3 to 3, x is equal to signal which is 000 and tetra 1, and we have used a subplot command also, stem command, to plot the following signal. Then I have given the following signal and title, which is title is original signal. Then again flipped signal title has been given to the second figure. The following is the output. Then moving on task 8. In task 8 we have to perform scaling of the signals. Our signal is signal 1 2 3 4 5 6 7 random. You can take any value. Then we have defined the scaling factor, which is very important in scaling. In this case we have the scaling factor is equal to 2, and then we have used a plot command to signal hold on command, and legend we have given original signal and scaled signal, and the output is being shown. In the output now you can see that the blue line is showing that the original signal and the red line is showing the scaled signal. In task 9 we have to perform shifting. In shifting we have t is equal to line space 0 10,000 sine function is being used, plot command is holding, and again we have given the values for legend, original and shifted. You can see the output, and in this output also the same case as the blue line is showing that the original signal and red line is showing the shifted signal. In task 10 we have to perform zero order. So t is equal to c line space 0 100, the frequency is being shown 10. Then we have defined our function x sine 2 pi fct. Ts is equal to 0.1 second. The following are the formulas. Then we have used a for loop so that Then we have used figure subplot command 211, then we plot command it, and then we gave the name to our figure, which will be continuous signal subplot 212, and stem command to plot, and the title of the second signal will be given as discrete time signal. This will give us the output of zero order hold. In the figure 1, this is continuous signal and this is discrete time signals, zero order hold. And then moving on to the last signal, which is of first order hold. Input signal is shown as 1 2 3 4 5 first of all. Then we have given T of S is equal to 0.1 and T of H is equal to 0.5. Then we use the following formula: N is equal to T H divided by T of S. Then I use the for loop and the figure subplot. Then I gave the name to the title as input signal, subplot 212, then plot command T output signal, and then gave the name to the second as the output signal. You can see the output. Thank you. This was from this lab report. Allah Hafiz.